Okay. All right, so in this case here, to find the y-intercept, you always let x equal 0 and just simply solve for x. Find out what f of 0 is. So 0 squared is 0. 4 times 0 is 0 minus 5. So here 0 plus 0 minus 5 ends up being negative 5. So that means that the y-intercept is the ordered pair 0, 5. All right, now part B is finding the x-intercepts. So to find the x-intercepts, you always let f of x equal to 0, or set f of x to be equal to 0. So f of x is at x squared plus 4x minus 5. And we're going to set that equal to 0 and find out what our x values are going to be. So in this case here, we're going to have to factor the quadratic into two binomials. Let's see, x squared breaks up as x and x. Now I need factors of negative 5 that would give me 4x as a middle term. Factors of 5 would be what? 5 and 1. And guess what? The 5 has to be plus and the 1 has to be minus, because the middle term is a plus, so the larger of the two factors will take that sign of the middle term. So it'll be x plus 5 times x minus 1 equal to 0. And then we set each binomial factor equal to 0, so that means I have x plus 5 equal to 0, or x minus 1 equal to 0. And for each equation, we'll solve for x. So for the x plus 5 equals 0, that would mean x is equal to negative 5. Or for the x minus 1 equals 0, that means x is equal to 1. So my two x-intercepts in this case will be negative 5, 0, and 1, 0. Those are the points where the graph of this parabola will be crossing the x-axis. Okay, so that's part B. Now part C is finding the coordinates of the vertex. Okay, and in this problem, I'm going to scratch out the part where it says by completing the square. So let's cross this out by completing the square, because the only thing we've been doing here is just using the formula for the x-coordinate of the vertex, even though we did talk about how to complete the square. So here we're going to use x equal negative b over 2a to find the x-coordinate of that vertex. Now, we need to identify a and b. Our a is the coefficient of the x squared term. In this case, that's the understood 1. The b is the coefficient of your x term. That's 4. So using x equal negative b over 2a, we'll just substitute the b with 4. So it'd be negative 4 divided by 2 times a will be replaced with 1. So here we're going to have negative 4 on top, then 2 times 1 would be 2. Negative 4 divided by 2 is negative 2. So the x-coordinate of your vertex will be negative 2. Now to find the y-coordinate of the vertex, we're going to take that x equal negative 2, substituted for x in our f of x function. So it'll be f of negative 2, and that's equal to that's going to be equal to, x will be negative 2, and that's squared, plus 4 times negative 2 minus 5. So in this case here, if we square the negative 2, that's going to be 4. And then 4 times negative 2 would be minus 8. and then minus 5. So when I do 4 minus 8, that's going to be negative 4. Negative 4 minus 5 would be negative 9. So the vertex of this parabola will be the ordered pair negative 2, negative 9. Okay. And then finally, part D is to use those points and a point symmetric to the y-intercept with respect to the x-axis of symmetry of the parabola to sketch the graph of that parabola. So part D is just simply the graph. And you will have a coordinate grid on your final exam to do the graph of that parabola. So already we know what our y-intercept is. That's going to be 0, 5. I mean 0, negative 5. So instead 0 would go down to negative 5. My x-intercepts are negative 5, 0, and 1, 0. Negative 5, 0 here, and 1, 0 is here. And then my vertex is negative 2, negative 9. That'd be to the left 2 and down 9. Now, the axis of symmetry, if you recall, is going to be that vertical dotted line going through the vertex. And it's a vertical dotted line going through the vertex. And it's going to be at x equal negative 2. Now, for an additional point, if you recall, if you look at the distance from this axis of symmetry to that y-intercept is 2 places to the right. So the other point on the left side must be 2 places to the left of that axis of symmetry with the same y-coordinate. Okay. So here we just use those 5 points and create the graph of that parabola. Okay. So this represents the graph of the parabola, f of x equal to x squared plus 4x minus 5. Okay. Are there any questions about problem number 16? All right, number 17 is using either substitution or elimination to solve the system of equations. Okay, so let me move to another sheet. In problem number 17, you have 3x minus 4y equals 11. Equation is 2x plus 3y equal negative 4. All right, now, I would prefer to use the elimination method because it'll be difficult to use substitution because you have to get y by itself and you're going to be dealing with some fractions here. Now, which variable would you like to eliminate, x or y? All right, let's eliminate the y because I got a minus sign here and a plus here. Now, what would be a common factor for 4 and 3? It'll be 12. So, if I want that minus 4y to be minus 12y, I need to multiply that top equation, that first equation, by 3. And if I want that 3y to become 12y, I need to multiply the bottom equation by 4. Sometimes you might have to multiply 1 or 2 equations in order to eliminate either x or y. And when I do that, if I multiply that top equation by 3, I'm going to have 3 times 3x, which is 9x, minus 3 times 4y, which is 12y, equal 11 times 3, which is 33. And then for the second equation, if I multiply it by 4, that'd be 4 times 2x, which is 8x, plus 4 times 3y, which is 12y, equaling to 4 times negative 4, negative 16. Now I can go ahead and add the two equations together. So as you can see here, 9x plus 8x is 17x, minus 12y and a plus 12y, they're eliminated, they add to 0, equals 33 minus 16, which is 17. So here I have 17x equals 17. And then divide both sides by 17. You'll get x is equal to 1. So here x equals 1 is these is that ordered pair. But that's half of it. Now we need to find out what y is. We could use either the first equation or the second equation and substitute the x with 1. So let's see, if I use that second equation of 2x plus 3y equal negative 4. And then replace the x with 1. So it'll be 2 times x, which is 1, plus 3y is equal to negative 4. So here 2 times 1 will be 2, plus 3y equals negative 4. And then to get 3y by itself, I need to subtract 2. So 3y is equal to negative 6. Divide both sides by 3. You're going to get y is equal to negative 2. So the solution, or the ordered pair that satisfies this system of equations would be 1, negative 2. Are there any questions about problem number 17? Problem number 18 is using Kramer's rule to solve this system. 4x plus 3y is equal to 15. And then 2x minus 5y is equal to 1. And here I want to solve this system using Kramer's rule. So that means I need 3 different determinants. One for d, the other one would be for d sub x, sub y. Now, of course, for the d, you have to use your coefficients for x and y. And you want to make sure that your x and the y are on the left side and the constant term is on the other side. So for the x coefficients, it's going to be 4 and 2. Your y coefficients will be 3, negative 5. And now for the d sub x. Instead of the x being in the first column, your constants will be to that, and then your y coefficients will be in the second column. So I still know my y coefficients are still going to be 3, negative 5. My constants are now going to be in the first column, 15 and 1. And then for d sub y, first column has your x coefficients. This time, your constants will be in the second column. So in this case here, my x coefficients are 4 and 2. The constants now, 15 and 1. For each one of these, we will find the determinant, which is a numerical value, and then find out what x and y are going to be. So the determinant for d is this: 4 times negative 5 minus 2 times 3, which is 6. And if I do negative 20 minus 6, I would get negative 26. D sub x. If I multiply 15 times negative 5, that would be negative 75 minus 1 times 3, which is 3. 75 minus 3 would be negative 78. And then for d sub y, if I do 4 times 1, it's 4, minus 2 times 5, 30. 4 minus 30 would be negative 26. And then from there, I can find out what x and y will be. X, of course, is d sub y divided by d. So here, d sub x, not d sub y. I use that for y. D sub x is negative 78 over d, which is negative 26. Negative 78 divided by negative 26 would be 3. And then for the y, that's your d sub y divided by d. And d sub y is negative 26. D is negative 26. Negative 26 divided by negative 26 will be 1. So the solution for that system of equations using Cramer's rule would be 3, 1. All right. Any questions about problem number 18? All right, number 19. Here we have a 3 by 3 matrix, and we're going to find its determinant. Let's see, here we got 3, negative 2, 1, 2, 4, and 3, negative 1, 5. All right, if you recall, when you're finding a determinant for a 3 by 3 matrix, first you would rewrite the first two columns. So here I'm going to rewrite that first column of 3, 2, negative 1. Second column, I'm going to rewrite that as negative 2, 4, and 5. And to get the determinant, we take the sum of each of these determinants going from the upper left to the lower right. So for this diagonal right here, 3 times 4, that's going to be 12, times 1 will be 12, and then plus the product of this diagonal. Negative 2 times 3, that's negative 6. Negative 6 times negative 1 would be 6, and then plus the product of this diagonal in this direction. 1 times 2, which is 2, times 5, which is 10. And then I'm going to subtract the product of each diagonal going in this direction, from the lower left to the upper right. So here, if I do negative 1 times 4, that's negative 4 times 1 will be negative 4. And then minus the product of this diagonal. 5 times 3, which is 15. 15 times 3 will be 45. And then minus the product of this diagonal in this direction. 1 times 2 will be 2. 2 times negative 2 will be negative 4. Now, let's clean this up a bit, and I'm going to go ahead and rewrite the 12 plus 6 plus 10. Minus a negative 4 will be plus 4, minus 45, and then minus a negative 4 will be plus 4. And then enter that into the calculator. Let's see, I have to do this in my head. 12 plus 6, that's 18, 28, 32. 32 minus 45 would be negative 13. Negative 13 plus 4 would be negative 9. Okay. All right, are there any questions about problem number 19? Okay, so that's how we find the determinant of a 3 by 3 matrix. All right, now number 20 is using the change of base property. Here we got log to the base 3 of 17. Log to the base 3 of 17. And here we want to apply that change of base property and round the answer to the nearest hundred, or to 2 decimal places. The way we apply the change of base property is this. You can either take the log or the natural log. Here I'm going to take the log, in this case, of the number itself, that's 17, and that will be divided by the log of the base. In this case, that base here is 3. And here I'm taking common logarithms here. So, here we press the log key, or the LOG button. And then type in the number 17 and then close your parentheses, because whatever the log of 17 is, it will be divided by the log, press the LOG button, of 3, close parentheses, and then hit enter. So what would our answer be to 2 decimal places? 2.58. So that's what log to the base 3 of 17 would be. Now, of course, you could use the ln if you want to, and you'll still get the same answer. ln 17, close parentheses, divided by ln 3, close parentheses. Same answer. All right, questions on number 20. All right, number 21 is to expand the logarithm in terms of log of m, log of n, and log of p. So here we got log of p to the 9th, and that's times the 4th root of n, divided by m to the 5th. And we want to expand this as far as possible using a combination of the product rule, the quotient rule, and the power rule for logarithms. So right off the top, I have a numerator and a denominator. That means I need to use which rule? The power rule, the quotient rule, or the product? Quotient rule, which will be, in this case, log of the numerator of p to the 9th times the 4th root of n minus the log of the denominator, that's m to the 5th. Keep in mind the log of a quotient is always going to be the difference of the individual logarithms. But here I've got log of p to the 9th times m to the 4th, the 4th root of n. What rule can I use here? Product rule. That can be expanded as a sum of their individual logarithms. So this will be the log of p to the 9th plus the log of the 4th root of n. I'm going to write that in exponential form. Bring down the n. The exponent for that n is the understood 1. This index of 4 will be your denominator. So the 4th root of n will be n to the 1/4 power minus the log of m to the 5th. Now for each of these terms, what rule can I use here? Power rule. That means we bring the power in front of the logarithm. So that means this 9 will be in front of log of p. The 1/4 would go in front of the log of n, minus this 5 would go in front of the log of m. Are there any questions about problem number 21? All right, number 22 is a logarithmic equation where we're going to have to check our proposed solutions here. So here we've got log to the base a of the quantity x plus 4 plus log to the base a of 6 equaling to log to the base a 2. And here I want to solve this equation. Now I want to make sure that I have a single logarithm on each side of the equation. The right side I do, but the left side, I need to condense that as a single logarithm using which rule? The product, the quotient, or the power rule? Product rule, because the plus sign tells me I have a sum of the individual logarithms. I can condense that by using the product rule. So I'm going to have log of a of, and I'm going to put the 6 in front of the x plus 4. And then that's equal to log to the base a of 42. Now here I can apply the one-to-one property. Okay? That one-to-one property says here, if you have log to the base b of m equaling to log to the base b of n, these expressions can be set equal to each other. So I can set 6 times the quantity of x plus 4 to be equal to 42. And then solve the equation for x. So if I distribute the 6 over the x plus 4, I will have, let's see, 6x plus 24 is equal to 42. And then subtract 24 on both sides. That means 6x is equal to 18 divided by 6. My proposed solution would be x is equal to 3. But of course, you are required to do the check on these proposed solutions here. So if I do the check here off to the side, I'll take the original equation and replace each x with 3. So I have log to the base a of 3 plus 4 plus log to the base a of 6 equaling to log to the base a of 42. Now, 3 plus 4, that's 7, so log to the base a of 7 plus log to the base a of 6 equaling to log to the base a of 42. Now, of course, the sum of the individual logarithms condenses as a log of the product. So I have log to the base a of 7 times 6 equaling to log to the base a of 42. And then 7 times 6 will be 42, so it'll be log to the base a of 42 equaling to itself. So that checks. Which means x equals 3 is the solution to that logarithmic equation. Are there any questions about problem number 22? All right. Another question. Again, you'll have to check your proposed solutions on this one. So here we got log to the base 6 of the quantity x plus 5 minus log to the base 6 of 7 equals to 2. Now here we have a logarithm only on one side of the equation. But of course we have to condense this left side. What rule can I use here? It's either going to be the product rule or the quotient rule. Quotient. So the difference of the individual logarithms is condensed as the log of the quotient. So I'll condense that as log to the base 6 of plus 5 goes in the numerator, and the 7 goes in the denominator, and it's equal to 2. And then next we will have to write this in its equivalent exponential form because we only have the log on one side of the equation. So in its equivalent exponential form, it would be 6 to the second, or 6 squared, is equal to that x plus 5 over 7. We're converting a logarithmic equation into its equivalent exponential form. So it'd be 6 squared is equal to x plus 5 over 7. Simplify this. 6 squared, or 6 times 6, will be 36, is equal to x plus 5 over 7. And then to get x by itself, well, I got the 7 in the denominator, so I need to multiply both sides of the equation by 7. And that x plus 5 over 7 needs to be multiplied by 7. So on the right side, these 7's divide out. So 36 times 7, that's 252. It's equal to x plus 5. And then to get x by itself, I'll subtract 5 on both sides to get x is equal to 247. All right, 247 is my proposed solution for this logarithmic equation. Of course, you have to do the check. So using the original equation, I'll replace the x with 247. (247) plus 5 would be 252, so I have log to the base 6 of 252 minus log to the base 6 of 7 is equal to 2. And of course, the difference of the individual logarithms would be the log of the quotient. So it'd be log to the base 6 of 252 divided by 7 is equal to 2. Now, 252 divided by 7 would be 36, so log to the base 6 of 36 is equal to 2. And of course, you can write this in its equivalent exponential form by doing 6 to the second equaling to 36. And when you square that 6, you will get 36. So that checks. So that means x equals 247 is the solution to that logarithmic equation. Okay. All right, any questions about problem number 23? All right, 24 and 25 are exponential equations. These you are not required to do the check. In 24, you got 10 raised to the x minus 7 is equal to 18, and you're going to round the answer to the nearest hundredth or to 2 decimal places. So in this case here, normally you would take the natural log on both sides, since the exponential expression is by itself. However, since it's a base 10, it'll be easier to take the log on both sides, or the log. So I have log of 10 to the x minus 7 is equaling to the log of 18. So I'm taking the log on both sides of this equation instead of the natural log. There's a property that says that if you have log to the base 10 of 10 raised to whatever your exponent is, it's going to be that exponent. So log of 10 raised to the x minus 7 would be x minus 7. And that's equal to log of 18. Now to get x by itself, we're going to add 7 to both sides. So here I have x is equal to, notice I'm going to put the 7 in front of the log of 18. Okay? And we're going to come up with our answer for x to the nearest hundred or to 2 decimal places. So if I do 7 plus, and then press the log key, and then 18, close parentheses, you're going to get this number. And what would that be to 2 decimal places? 8.26. Now, if you write that as log of 18 plus 7, you want to make sure that only the 18 is in parentheses and not the 7. Because you're only doing the log of 18, and then whatever that is, you're going to add 7 to it. Okay, let me show you what happens if you do log of 18 and then do plus 7. You're going to get a wrong answer. You want to make sure only the 18 is in parentheses. So this is our approximate value for x. And that 7 plus log of 18, that's your exact value. Are there any questions about problem number 24? 5 is another exponential equation, 2 raised to the 2x minus 1 equal to 32. All right, with that, you want to make sure that you can set your bases to be equal to each other, because 32 can be written as 2 to some power. Okay, so in this case here, if I divide 2 into 32, that's going to be 16 times. Divide 2 into 16, that would go 8 times. Divide 2 into 8, that's going to go 4 times. Divide 2 into 4, that will go 2 times. And then divide 2 into 2 itself, it's going to go 1 time. How many times does 32 use as a factor? 5 times. So 32 can be written as 2 to the 5th. So I have 2 raised to the 2x minus 1 is equal to 2 raised to the 5th. Now, since my bases are the same, I can set this exponent to be equal to that exponent. So I can take that 2x minus 1, set that equal to 5, and then solve this equation for x, which means if I add 1 to both sides, that means 2x is equal to 6. Divide both sides by 2. Xn will be equal to 3. All right, so x equals 3 is the solution to that exponential equation. Any questions? Okay. All right, number 26. Ask, how long will it take for $5,000 to grow to $7,500 if the principal was invested at 7% annual rate interest compounded continuously? And you're to round your answer to the nearest tenth or to one decimal place. So for number 26, we have a principal of $5,000. We want that to grow to $7,500. That would be your amount. We have an interest rate of 7%. What is 7% as a decimal? 0.07. And it says compounded continuously, so that means we need to use this formula for continuous compounding. A is equal to P times e to the RT. And then substitute into this compound interest formula to find out what T is. Our A is $7,500, equaling to P, which is 5,000, times e to the R, that's going to be 0.07, times T. Now we need to get the e to the 0.07t by itself, the exponential part. It's being multiplied by 5,000, so we need to divide both sides by 5,000. So here's 7,500 divided by 5,000. That'd be 1.5. So I have 1.5 equaling to e to the 0.07t. And then since e and the natural log are inverses of each other, I can take the ln on both sides of this equation. I'm taking the natural log on both sides. So I have Ln of 1.5 on the left side. That's equal to, and there's a property that says if you have Ln of e to whatever your exponent is, it's going to be that exponent. So Ln of e to the 0.07t will be 0.07t. And then to get t by itself, we divide both sides by 0.07. So in this case here, if I type in Ln, and then 1.5, close parentheses, divided by 0.07. So to one decimal place, what would t be equal to? 5.8. And it'll be 5.8 years. So it's going to take approximately 5.8 years for a $5,000 investment to reach $7,500 at 7% compounded continuously. Any questions on number 26? All right, number 27. Here we're going to solve a system of linear equations in 3 variables here. So in this case here, we got 5x plus 6y minus 2z is equal to 2. 2x minus y plus z is equal to 2. X plus 4y minus 2z is equal to 0. Now, of course, you have to pick 2 equations and eliminate 1 variable, and then pick another set of equations and eliminate that same variable as well. That way you have 2 equations and 2 variables, where you can reduce it to an equation in a single variable and solve for x, or y, or z. Let's see here. I'm going to use equations 1 and 2. In fact, let me label this as equation 1, that's equation 2, and that's equation 3. So, let's see, equation 1 would be this. That's the 5x plus 6y minus 2z is equal to 2. And let's see, equation 2, I have 2x minus y plus z is equal to 2. Which variable would you like to eliminate, x, y, or z? Okay, we can eliminate the y. Now notice I got 6y, but if I want that minus y to be minus 6y, I need to multiply that bottom equation by 6. Do that, I'm going to have 5x plus 6y minus 2z is equal to 2. The bottom equation, 6 times 2x will be 12x. 6 times the minus y would be minus 6y, plus 6 times z would be 6z, equaling to 2 times 6, which is 12. So here the 6y's are eliminated. So one equation I have would be 5 plus 12x is 17x, minus 2x plus 6z will be a plus 4z, equaling to 2 plus 12 will be 14. This will be equation 3. No, equation 4, because I got equation 3. Actually, it's going to be 4. Equation 4. So now let's use another pair of equations. Let's try 2 and 3. And eliminate that y, since we already eliminate a y in equations 1 and 2. So equation 2 will be 2x minus y plus z is equal to 2. Equation 3, that's x plus 4y minus 2z equals 0. Now, if we're going to eliminate the y, We got a 4y, but if I want that minus y to be minus 4y, I need to multiply that top equation by 4. So if I do 4 times 2x is 8x, minus 4 times y would be minus 4y, and then 4 times z will be plus 4z, equaling the 2 times 4, which will be 8. Now bring over the third equation, x plus 4y minus 2z, equaling the 0. And you're going to see that the minus 4y and the plus 4y added together give you 0. So here, 8x plus a 1x, that's 9x. 4z minus 2z will be plus 2z is equal to 8 plus 0, which is 8. This will be equation 5. So now we're going to use equation 4 and equation 5 to eliminate either the x or the z. So let me write down equation 4, which is 17x plus 4z is equal to 14. Equation 5 was 9x plus 2z is equal to 8. Now, which variable would you like to eliminate, x or z? Let's eliminate the z. Okay. Now I got 4z, but I need to make this one minus 4z. Well, I got 2z, so if I want that 2z to be minus 4z, I need to multiply that second equation, or equation 5, by negative 2. So I'm going to bring over the 17x plus 4z is equal to 14. Now if I do negative 2 times 9x, that's negative 18x. Negative 2 times plus 2z will be a minus 4z. And negative 2 times 8 would be negative 16. And here, 4z and minus 4z add to 0. 17x minus 18x, that's going to be a negative 1x, or just negative x, equaling to 14 minus 16, negative 2. So I got negative x is equal to negative 2. But if I divide both sides by negative 1, x is equal to 2. So here, x equals 2. We know that's one of our ordered pairs for this system of equations in 3 variables. Now we need to find out what y is and what z is going to be. Let's first find out what z is using either equation 4 or 5. So here's what I'm going to do here. Let's see, if I use equation, let me use equation 5. That's at 9x plus 2z is equal to 8. X equals 2. So it'll be 9 times 2 plus 2z is equal to 8. 9 times 2 will be 18 plus 2z is equal to 8. Subtract 18 on both sides. So that means negative 2z is equal to negative 10. And then divide both sides by negative 2. That means z is equal to 5. Where I'm getting negative from? It'll be negative 5. So z is negative 5 and x is 2. Now I need to go back to one of my original equations, either equation 1 or equation 2, to find out what y is. And I'm going to use equation 3. So here, that equation 3 was x plus 4y minus 2z is equal to 0. Replace the x with 2 and the z with negative 5. So here, this will be 2 plus 4y minus 2 times z, which is negative 5, equals 0. Bring down the 2 plus 4y, and then minus 2 times a negative 5 would be plus 10, equal to 0. 2 plus 10 would be 12, so 4y plus 12 is equal to 0. Subtract 12. That means 4y is equal to negative 12. Divide by 4. Y is equal to negative 3. Okay? So the solution for this system of equations in 3 variables will be x is 2, y is negative 3, z is negative 5. Okay? And I'll leave the check up to you. All right. Are there any questions about problem number 27? Okay, does everyone have this? All right, number 28 is solving the system by using the substitution method. And in this case, you got x plus y is equal to 3. And the other equation is y is equal to x squared minus 6x plus 9. All right, and here I want to use the substitution method. Well, notice I have y is equal to x squared plus 6x plus 9. Now, my equation is that x plus y equals to 3. Well, since y is equal to x squared plus 6x minus 6x plus 9, I can just take that, substitute it for the y in the first equation. So here I'm going to have x plus, and this y will be replaced with x squared minus 6x plus 9. And then that's equal to 3. All right, so let's combine some like terms here. Bring down the x squared. X minus 6x will be a minus 5x, and then plus 9 is equal to 3. Now, what I want to do here is get all the terms on one side and a 0 on the other side. So I'm going to move the 3 over by subtracting 3 on both sides. So that means I have x squared minus 5x. 9 minus 3 will be plus 6 is equal to 0. Now I can factor that into 2 binomials here. So for the x squared plus 5 minus 5x plus 6, I need factors of 6 that would give me negative 5x as a middle term. It'd be negative 2 and negative 3. They both have to be negative. Since the middle term is plus, a minus and the last term is a plus. So I have x minus 2 times x minus 3 equal to 0. And then we set each binomial factor equal to 0. So this means x minus 2 is equal to 0. X minus 3 is equal to 0. And then for each equation, we'll solve for x. So for the x minus 2 equal to 0, that means x is equal to 2. And then for the x minus 3 is equal to 0, that means x has to be equal to 3. So I know what my x coordinates are for these ordered pairs, x equals 2 and x equals 3. Now for each x, I'm going to find out what y is. And I'm going to use the equation y is equal to x squared minus 6x plus 9, since y is equal to something. Now for x equals 2, that means y will have to be equal to, replace the x with 2, so it'll be 2 squared minus 6 times 2 plus 9. So here y is equal to 2 squared will be 4 minus 6 times 2 will be 12 plus 9. Let's see, 4 minus 12, that's negative 8. negative 8 plus 9 would be 1. So one ordered pair would be 2, 1. Now, for the other ordered pair, when x is equal to 3, here we're going to replace the x with 3 in that equation y equal x squared minus 6x plus 9. So it'd be y equal 3 squared minus 6 times 3 plus 9. So 3 squared would be 9 minus 6 times 3, which is 18, plus 9. 9 minus 18 is negative 9. Negative 9 plus 9 is 0. So the other ordered pair would be 3, 0. So the two ordered pairs that satisfy this system of nonlinear equations would be 2, 1 and 3, 0. Any questions on number 28? All right, number 29. We're going to solve using the addition method here. So here we got 4x squared minus 3y squared equals negative 11. And the other equation is 5x squared plus 2y squared is equal to 38. So which do you want to eliminate, the x squared or the y squared? Well, it'd be best to eliminate the y squares because I got a minus here and a plus here. What would be a common denominator? I mean, a common multiple for 2 and 3. Let's use 6. So if I want that minus 3y squared to be 6y minus 6y squared, I need to multiply that equation by 2. For the 2y squared to be 6y squared, I need to multiply that equation by 3. So if I do 2 times 4x squared, that would be 8x squared. Minus 2 times 3y squared would be 6y squared. And then 2 times negative 11 would be negative 22. For the second equation, 3 times 5x squared would be 15x squared. 3 times 2y squared would be a plus 6y squared, equaling to 3 times 38 would be 114. Now we're going to add the two equations together. 8x squared plus 15x squared will be 23x squared. The minus 6y squared and the plus 6y squared add to 0, so that's gone. Then that's going to be equal to negative 22 plus 114. That's going to be 92. So I got 23x squared is equal to 92. And then divide both sides by 23. That means x squared is equal to 23 goes into 92 4 times. So x squared is equal to 4. Now, opposite of squaring something would be to take square root and also include plus or minus. That means x will have to be plus or minus 2. Okay, so no, x is going to be positive 2 or negative 2. So for each of these x values, I'm going to substitute in either one of the original equations here to find out what y is. And here I'm going to use the second equation here in this case. Starting with the x equals 2, I'm going to use that 5x squared plus 2y squared is equal to 38. And replace the x with positive 2. So it'll be 5 times 2, and that's squared, plus 2y squared is equal to 38. Using order of operations, if I square the 2, that's going to be 4. 4 times the 5 in front, that will be 20. So I got 20 plus 2y squared is equal to 38. Subtract 20 on both sides. 2y squared is equal to 18. Divide both sides by 2, you'll get y squared is equal to 9. And if you take the square root on both sides, include that plus or minus symbol, that means y would be equal to plus or minus 3. So I know for x is equal to 2, it's going to be positive 3, and also for x equals 2, it's going to be negative 3. All right, now for x equal negative 2. We're going to use that second equation and replace the x with negative 2 this time. But pretty much you're going to see that you're going to get the same value for y. Because if I square negative 2, that's going to be positive 4 times the 5 in front, that will be 20, plus 2y squared is equal to 38. And then subtract 20 on both sides. That means 2y squared is equal to 18. Divide both sides by 2, you'll get y squared is equal to 9. That means y is equal to plus or minus 3 as well. So, for negative 2, I'll have positive 3, and for negative 2, it would be negative 3. So here I got 4 ordered pairs that will satisfy this system of non-linear equations. 2, 3, 2, negative 3, negative 2, 3, and negative 2, negative 3. Any questions about problem number 29? And finally, problem number 30. Does everyone have this? Here we're going to graph the solution set of the system of inequalities or indicate that the system has no solution. So number 30, we have this 3x minus 4y is less than or equal to 12, and the other equation is 3x minus 2y is greater than 6. Okay, so we're going to graph both of these on the same coordinate plane and find out their intersection. Let's start with the first equation, 3x minus 4y is equal to 12. Is less than or equal to 12. And I'm going to treat this as 3x minus 4y equal to 12. And then, in this case here, find my x and y intercept since the x and the y are on both sides of the equation. So for the x-intercept, you of course always let y equals 0 and solve for x. So it'll be 3x minus 4 times y is 0. That's equal to 12. 4 times 0 will give you 0, so it'll be 3x is equal to 12. And of course, x has to be equal to 4. My x-intercept would be 4, 0. And then for the y-intercept, and I said this all wrong, that should be let y equal 0 for your x-intercept. For your y-intercept, you let x equal 0. So now you got 3 times x, which is 0, minus 4y is equal to 12. 3 times 0 is 0, so negative 4y would be 12. Divide both sides by negative 4, you'll get y is equal to negative 3. So 0, 3 will be your, 0, negative 3 will be your y-intercept. All right, so 4, 0 is my x-intercept. 0, -3 is the y-intercept. Now, would that line be a solid line or a dashed line? Based on that inequality. It's solid. Okay, so this is what the half plane will look like. And I will need a test point to determine whether I need to shade the plane above or the one below. Okay, so a test point would be 0, 0. The good test point would be that ordered pair 0, 0. So in the first equation, I just replace the x and the y with 0. So it'd be 3 times 0 minus 4y. Which is 0. I want to know if that's less than or equal to 12. 3 times 0 is 0, minus 4 times 0 is 0. 0 minus 0 is 0. Is 0 less than or equal to 12? Is that a true statement? Should be, yeah. So that means I shade the region containing the test point. So I'm going to be shading this region up here for now. And then next is the equation 3x minus 2y is greater than 6. This up a bit. Again, I'm going to treat this as 3x minus 2y equal to 6. And here I'm going to use x and y intercepts here. So for the x-intercept, of course you let y equal 0, so that means I'm going to have 3x minus 2 times y is 0. That's equal to 6. Well, 2 times 0 is 0. That's going to leave me with 3x is equal to 6. X has to be equal to 2. So 2, 0 is my x-intercept. And now for the y-intercept, we let x equal 0. So it'd be 3 times 0 minus 2 times y is equal to 6. 3 times 0 is 0. That would leave me with negative 2y equal to 6. That means y has to be equal to negative 3. So I'm going to use a different color. I'm going to use the purple for this one. All right, 2, 0 is right here. 0, negative 3 is right here. Now, would that line be solid or dashed? It's going to be dashed because it's strictly greater than. So here, I'm going to draw a dashed line to show that this line will not be included. And now, let's use a test point for this. Again, I can use 0, 0 because that point is not on the graph. And then substitute the x with 0 and the y with 0, so it'll be 3 times 0 minus 2 times y, which is 0. That has to be greater than 6. 3 times 0 is 0, minus 2 times 0, that's 0. Is 0 greater than 6? No, that's a false statement, so we shade the region that does not contain the test point. So in this case here, here's 0, 0, we have to shade the one below it, the region below it. And then we find the intersection of these two, where these two graphs will intersect. And if you look at it, this purple and this green are intersecting in this area right up here. So this would be the shaded region for the intersection of those two, for that system of inequalities. So this orange shaded area represents the graph of the two inequalities. 3x minus 4y is less than or equal to 12, and 3x minus 2y is greater than 6. All right, are there any questions about problem number 30?